Hello, geometry folks. Today we're going to be talking about similar right triangles. So we've already talked about similar figures and similar triangles, but now we're going to be talking about specifically right triangles. And when I say three in each picture, we're going to have some complicated images in these examples. So we're going to have three triangles within one in each diagram. So what you're going to need today is a pen or pencil, and then I recommend three markers or three colored pencils or highlighters, just three different colors so that you can kind of pick out the three different triangles we're talking about, and if you so like, a calculator. So the first thing I want you to get in your notes is the parts of a right triangle. So I want you to draw a right triangle, and then we're going to label all the parts of it. The first thing about a right triangle is obviously the right angle, so the 90-degree angle, and we always denote that with a symbol like a little box. Across from the 90-degree angle, we call that side the hypotenuse. Hypotenuse is how you spell it. And then we have the other two sides of the triangles called legs. So this is a leg and this side is a leg. In every single case of a right triangle, other than when a right triangle is an isosceles triangle, you will have a long leg and a short leg, unless the right triangle is also isosceles. So we need to make sure that we know the difference between the long leg and the short leg and the hypotenuse, solely because when we're talking about similar triangles and similar right triangles in these next examples, we want to pair up the corresponding parts, such as long leg to long leg, short leg to short leg, and hypotenuse to hypotenuse. And you'll see what I mean as we dive into some examples. Before we dive into some examples, let's talk about the similar right triangles theorem. That theorem states that the altitude, or also the height of the triangle, so in our little block image, this would be the altitude or the height of the triangle. The altitude to the hypotenuse of a right triangle divides the big triangle into two triangles that are similar to each other and the original triangle. So this altitude or the side length CD divides the triangle ACB into two littler triangles, our red triangle here and our blue triangle here. And the blue, red, and the black triangle are all going to be similar to each other. The two small ones are similar to each other and the original one when they're added together. So this theorem will come in handy when we're going to set up some proportions from our problems. Okay, so for each of these problems, we're going to need three colors to designate the triangles, which are the small triangle, medium triangle, and those two added together are going to make up our bigger triangle. I'm going to use red for my small triangles, blue for my medium, and green for my large. So when we do these examples, it's easiest to solve and set up the proportions if we redraw all of the three triangles separately. So let's draw the first triangle, and that's going to be the small one. The small triangle is this one in red right here. We want to redraw that separately away from our image that we've been given. And now we want to draw our medium triangle, which is this blue triangle on that image. And we want to move that. And then we also want to rotate it so that it's at the same angle, if you will, or so that it looks more similar to our eye when we are comparing the two, the small and the medium. And then last but not least, we want to redraw our green triangle, which would be this triangle right here. And again, we want to draw it so that it looks similar to our eye. So we want to make sure that we have labeled all of our right angles, and then we also know where all of our hypotenuses and short and long legs are. So looking back at our small triangle in this image, remember that was this triangle right here. We said that the short leg was 7 units long, and we didn't know anything about the hypotenuse or the long leg. So now we're going to look at the medium triangle, which was this triangle right here, remember? We said the hypotenuse of that triangle was x, and we also said that the hypotenuse or the long leg of that triangle, is 17. So let's label that on my new triangle that I drew over here, on my blue triangle that I drew separately away from the image that was given to us. And then last but not least, on the big triangle, this whole triangle, we're saying that the hypotenuse, which is this side, is 7 plus 17, and that's 24. So on my green triangle, I'm going to write 24 by the hypotenuse. And then on the long leg, that value is still x. So now I can set up a proportion from the medium triangle to the large triangle. I'm going to do hypotenuse over hypotenuse. So I'm going to do x over 24 is equal to the long leg over the long leg, which is 17 over x. And now all I have to do to solve for or find the value of x is to cross multiply. So 24 times 17, that's 408, is equal to x times x, which is x squared. Whenever we have x squared equal to a number, all we have to do is take the square root. That's how we get x by itself. So we're going to take the square root. 408 does not come out evenly, so we're going to have to break up the square root. We're going to have to break it into a perfect square and another factor. The highest perfect square, remember perfect squares are things like 1 squared, which is 1, 2 squared, which is 4, 3 squared, which is 9, 16, 25, and so on and so on. The highest perfect square for 408 is 4. And 408 divided by 4 is 102. So we're going to say that the square root of 408 is equal to the square root of 4 times the square root of 102. I'm going to write over here now, which can be simplified as the square root of 4 is 2, and we can't simplify the square root of 102 any farther. So that's what my x value is. All right, let's try some more. All right, moving on to number 2. We're going to redraw our triangles, right? So let's start with our small triangle, and then we'll label our right angle. Our small triangle in our black image is this one right here. So we're going to say x is the hypotenuse, which is what was given, and the short leg is 6. So grab your other color. For me on my medium triangle, it's going to be blue. We're going to draw our medium triangle, designate our right angle, and then our medium triangle in the left-handed image is this one right here. And the only thing they gave us on the medium triangle was that the long leg was 14 units long. Grab your third color. For me, it's green. And we're going to do the entire big triangle now. So that's this one right here. Redraw that off to the side. And we're going to label our right angle. And we see in our green one here, our short leg is equal to x units long. And then our hypotenuse, we know nothing about the long leg, which is right here, but our hypotenuse, or this distance right here, is 6 plus 14, which is 20. So now we are going to use, it looks like we have 2 pieces of information from the small triangle and the large triangle. So what I'm going to do here now is set up a proportion. So I'm going to compare the hypotenuse to the hypotenuse, which is going to be x over 20, equal to the short leg over the short leg. Remember, if we're going from small to big on one ratio, we're going to have to go small to big on another ratio. So if we're going small to big on over x, and now all we have to do from here is cross multiply. X times x is going to give me x squared equal to 20 times 6, which is 120. In order to solve for x, I have to do the square root to both sides, take the square root from both sides, and x is equal to, we have to break this square root 120 down farther. And the highest perfect square that goes into 120 is 4. 120 divided by 4 is 30, so that breaks into the square root of 4 times the square root of 30 times the square root of 30. And so x, if we simplify this now, square root of 4 times the square root of 30, that comes down to 2 times the square root of 30. If you're having trouble simplifying radicals or breaking them down into perfect squares and non-perfect squares, we can work on that when we get back from the weekend. So moving on to number 3. We're going to start with drawing our small triangle, labeling our right angle. Our small triangle in our original image is this one that I highlighted in red right here. Our short leg on our small triangle is A units long. our hypotenuse is B units long, and our long leg is 10 units long. So grab another color for your medium length triangle, and we're going to draw our medium length triangle and designate our right angle. And in our original image, this would be my medium sized triangle. The base, or the short leg, I should say, is 10 units long. The long leg is 24 units long, so we're labeling that on our new drawn blue triangle or medium triangle, and our hypotenuse is 26 units long. So grab your other color. For me, it's green. We're going to redraw off to the side a right triangle, designate the right angle. My short leg on the big triangle, which is this huge triangle in our original image. My short leg is B again. My long leg is 26 units long. And then my hypotenuse is 24 plus A. It's these two distances added together. So 24 plus A. And we are trying to solve for A and B. So if we look at the small triangle and the medium triangle, we can compare A and 10, the short leg, and 10 and 24, the long leg, in order to solve for A. So let's set that up as a proportion. A over 10 is equal to 10 over 24. So from here to solve for A, all we have to do is cross multiply. A times 24 is 24A. 10 times 10 gives me 100, so 24A is equal to 100. Now we have to divide by 24 on both sides, divide by 24. A is a funky decimal, which is 4.16 with the 6 repeating. Now, if we want to find B, there's lots of different ways you can set up proportions, but I'm trying to do it in such a way that all I have is one variable and the rest numbers. So if I compare the medium triangle and the large triangle, now I can look at the short leg and the short leg, so 10 and B, and the long leg, 24, and the other long leg, 26. So if I want to set up my proportion for this, I could say 10 over B is equal to 24 over 6. Short leg over short leg is equal to long leg over long leg, from the medium triangle to large. So I went medium to large in my first ratio and medium to large in my second ratio. So from here, all we have to do is cross multiply. B times 24 is 24B. 10 times 26, that's giving me 260. So my new equation becomes 24B is equal to 260. Divide both sides by 24. Divide by 24. B is equal to the approximate decimal of 10.83 with the 3 repeating. So those are my two answers for A and for B. I want to thank you for taking good notes, and I will see you soon.